Errors in calculations, level 7, grade C. Okay, so we're going to look at two types of data for this. We're going to look at continuous data and discrete data. The reason we're going to do continuous first because that's the more common type. Now, when you're measuring something, either a weight or a length or a capacity or something that you're measuring, then there are a lot of values that it could take, and often we round it to the nearest something or other depending on what we're measuring with. Now the example we're going to look at here in a minute is of an apple to the nearest gram, but before that let's just think about measuring a length. So if I bring a ruler in to have a look at the values on here, so if I'm measuring a length for 1 centimetre, that's 1 centimetre, the nearest centimetre is 1 centimetre, that could have been anything between these sort of values roughly. Okay, anything around here would be rounded to 1. Now the boundary that causes the most problems with this is the one above the higher boundary, because normally when we get to halfway we round up to 2 or the next one up, and that causes a bit of issue in this topic. I'm going to try and explain that in a minute, but essentially what we're looking at here, to the nearest whole number we are going from 0.5 below to the 0.5 above, and essentially that's what we do throughout this topic. So when I'm measuring an apple to the nearest gram, 58 grams could be, if I've got 58 grams on a scale, so we've got a weighing scale that goes up on a scale, so the one above is 59 grams and the one below is 57 grams. So 58 grams could have been as little as halfway between 57 and 58, and as much as just, well, essentially halfway between 58 and 59. Now when we're doing this, I don't want to get into the argument of worrying about the fact that this would be rounded up. Just take from me, when you're doing calculations with errors, you always use the 0.5 boundary, so you don't worry about the fact that it would round up if you're measuring it. Any value up to this value will be rounded down to 58. So this value is 58.5 would be the higher value, and this value of 57.5 would be the lower value. So that's actually this way around. So the least it could be is 57.5. No problem with that. Everybody gets that fine. A lot of people would like to write 58.49 recurring, or 49999, because they think that's the biggest number, less than 58.5. But 58.49 recurring is indeed 58.5. A nice little demonstration of why 58.49 recurring isn't really helpful here is if I bring a calculator in, and these modern calculators that have a recurring decimal button on this one here, so if I type in 58.4, then I use this button and put a recurring 9 in there and press equals, it actually gives us the value of 58.5. What a lot of people don't realise is that there are more than one way of writing some decimals, and 58.49 recurrent is in fact equivalent or exactly equal to 58.5. So this notion of 49 recurring is a sort of a fallacy that people shouldn't really use, because it makes calculations very difficult. This is a much easier number to calculate with, and this value is in fact this number, so you might as well use the correct number. What we do to try and alleviate these difficulties, if I was talking about the value itself, I would write it like this. So I'd write that the value of the weight could be between these two values. What we would say it is less, 57.5 is less than or equal to x, the weight, and that is only less than 58.5, so we're not actually including this value. And that's probably the best way around this sort of thing. But when we're doing calculations with boundaries, we always use the 58.5 because it's very difficult to calculate this value, and even if you did calculate it on these calculators, it would still be using the 58.5 anyway, so you might as well use it to start with. Okay, so that's the basics of errors in boundaries. If you think about the next number above, the next number below, and go halfway between them, you shouldn't get this wrong. If it was to the nearest tenth of the value, so if we were talking about this was 58.6 to the nearest tenth, then we would think about the number above that, which is 58.7, and the one below it, 58.5, and then we go halfway between that 58.6 58.6, so we go halfway between those, 58.65 and then 58.55, and that would be our lower boundary and that would be our upper boundary. If you keep that idea in mind, then you shouldn't get these wrong. Okay, discrete data, you've got to be careful because you can get into a sort of false sense where you're going to use these 0.5 boundaries all the time, but if you're looking at discrete data like people, if it was reported that 2,700 people attended a football match to the nearest 100 people, then we could do the same idea. 2,600 would be the 100 below, 2,800 would be the 100 above, and we go in between those, we'd have 2,650. Now this upper boundary, okay, we've got to be careful because we don't have this problem with decimals, because we can't have a fraction of a person, and we certainly can't have 2,750 because that rounds up. So in discrete people, we have 2749 is the value we should be using there. So be careful with discrete. Continuous, we have this issue that we can get very, very, very close to this value but not actually use this value, so we just tend to use the value. But with discrete, because we're just jumping from one person to the next, there's nothing in between, we don't use the halfway value, we use one less than it. Okay, so that should answer all the questions. So this one, least number of people could have been at the match, is 2650, and this one is 2749, because definitely if it was 2750 it would be reported as 2,800. Okay, and one last thing I'm going to leave you with, just to mess you up completely, is to think about what happens with age. It doesn't really act like continuous value, although it should do because it's time, and it's not discrete because it's time. But if you think about somebody's age, they are, say somebody is 16, or when do they become 16? Well, they become 16 on their 16th birthday, and not before that. If it's the day before the 16th birthday, they're still 15. We don't round up to 16 when somebody is still 15. So if you're saying somebody's age to the nearest year, you're actually saying they either were born, you know, it's their birthday, or it could be up to the day before their next birthday. So age is a little extra one that you need to be careful of. It's very rarely asked, but occasionally they throw it in just to mess people up, so think about that one separately.